As you can see, Gien is not on stage with me. Basically, the idea is we prepared this whole thing together. We were going to present it together, but we're not, because now I can blame her for all the slides that you don't like. I'm Mathias. I work with Gien in Aartling. We are a software consultancy. We help organizations around software strategy, architecture, domain modeling, design, organization, that sort of thing. And we are here as sponsors as well, so come say hi at the booth. This is us. So who has any sort of background or knowledge about domain-driven design, bounded context? Okay, forget everything you know. Who doesn't have any, who hasn't heard of bounded context, doesn't know what it is at all? Okay, you're screwed. Don't worry, don't worry. So who has worked on a system that was very hard to understand? That's a lot of it. We sort of accept that in this industry, right? That we have these sort of systems, and it bothers me. So what I'll try to convince you of is that the things we're doing for organizing systems, right? We are doing sort of very technical organization. We always, microservices have had a big moment in the last 10 years or so. But there's other ways to organize our systems around. And then in DDD, it's sort of, domain boundaries. But I think that's sort of a very limited interpretation of what domain-driven design is about, because it's not just domain-driven, right? It's also design. Design is about how you do things that work for you and for your organization, for your environment. So it's form and function and all these things combined. And just following sort of the domain boundaries is not going to be enough. So a bounded context is in DDD, which is about 20 years old now, but I haven't found that idea in anything else, so I think it's an invention of Eric Evans. But the idea is it's something that we as designers can do. It's not just the domain boundaries that we get from the business. Oh, we're in warehousing and we have these areas. It's how we can organize our system around concepts, right? About things in our model, in our domain, that we need to be together or separated. That because it works for us as designers, because it works for understanding the system, because it works for grouping things conceptually in a way that helps us achieve stuff. And I always talk about the same sort of 5 topics. This is just sort of a different angle where I'm trying to explain this as you're using bounded context to manage the understandability of your system. Right? So you can group things based on what do we need to understand together, or what can we understand without having to understand something else. Right? That's fundamentally at the core of what bounded contexts are for. It's for us as not just designers, but other stakeholders, domain experts, product people, customers, depending how close they are with the development. But it's, can we benefit from organizing these concepts, these meanings, these terms, these models in ways that help us? And I hope that will become more clear with an example. So the idea here is a warehouse management system. Maybe you've worked on something like that. The way a warehouse works is fundamentally very simple, right? Stuff comes in on trucks or whatever. It needs to be unloaded. All of that is called inbound, and there's somebody checking if the right stuff is in there, etc. And then it needs to be moved somewhere in the warehouse. That's called put away. Right? We give it a location, ideally in a way that we can find it back later, obviously, or you'd have a very sloppy warehouse. And then outbound is we get an order from a customer, and we need to order pick, we need to collect stuff, package it, and ship it. So we can organize around that, right? We can say these are 3 conceptual boundaries, right? We have all the concepts related to inbound, separate. We have everything for put away, everything for outbound. That means that so the whole process of inbound is in one place, right? Conceptually, right? I'm not talking about technical boundaries. We'll discuss that more later. But if we organize like this, it looks good, right? It's understandable. You have this, stuff comes in, we do everything we need to do, and then we hand it over, right? We probably, technically, we have maybe a message going from one thing to another. Okay, we've received these goods now. Now it's your job, put it in the warehouse somewhere, I don't care how you do it. So we are conceptually separated, right? The only thing we need to agree on, call it an API or a contract, but it's the message of how we tell, put away, hey, we're ready with this stuff, it's your job now. So 3 black boxes, right? So that works all fine. We can build a big modular monolith with a single database. We could build microservices that are actually using this same database and sharing information that way, which is sort of an anti-pattern, but it exists all over there in the wild, so maybe you've worked on something like that. Or we can do, what the real microservices are supposed to be. So 3 different services, 3 systems, each with their own storage and everything completely isolated with just the messages going in between. But I want you to sort of forget technical boundaries. We're just talking about, in the rest of this presentation, conceptual boundaries, right? What do I need to know about this thing to understand this other thing, right? And in this picture, I don't need to understand anything about inbound to do put away, except for this little bit of communication. Same way with outbound, I just need to ask, I need to know where the stuff is, although it already gets messy there, as we'll see in a moment. I want to show this a bit more to really hammer that idea down, right? So a system boundary, service, component, module, whatever you want to call it. A domain boundary. Domains is how we perceive the business, right? Or how the business perceives itself, right? We are in warehousing. We have an inbound domain. We have other domains. We have invoicing. We have stuff like that. Those are all domains or subdomains. But it's how the business sees itself. It's what business are we in? What activities do we do? What sort of knowledge do we have? That's our core domain, probably. Right? Maybe if you're in trading, then financial trading is your core domain, but there's a whole bunch of other subdomains you have to deal with. So this understanding of separation in the business is historic, right? It grew there for a reason, because it helped business to organize, because historically businesses were doing stuff with paper and etc. before software. So it's not designed for us. Right? It's not that somebody says, hey, let's split up domains in a way that in 100 years when they invent software, they can build software in an ideal way. So this sort of picture doesn't exist in the real world, where it's really nicely bounded. And then bounded contexts are really what concepts belong together conceptually, right? And that we as a designer choose to organize. So I really want to hammer that difference, right? Of course, technically, we can split up things. The domain and the subdomains are structured in a way because of historic reasons and the company and context and everything. Bounded context is our choice as software designers. This is where I draw a line. It can overlap, right? It can be that we have a single bounded context that consists of multiple modules. It can be that a single bounded context manages multiple subdomains. Why? Because we chose to do it that way. Or because we have a big legacy ball of mud and all the domains are in there together, all the concepts are mixed. You can say, well, we didn't choose to do it that way. Well, it's still a design choice in my book, because if the business doesn't choose to split up that ball of mud, it's a design choice to leave it that way. It might be a good one for the business or bad, because maybe it's too expensive, maybe it's not worth it, I don't know, but it is still a design choice, right? So I treat everything that has an impact on the design as a design choice, whether you really want it that way or not, whether you're happy with it or not. So you have sort of these different patterns in the wild, right? You can have microservices, but if 5, technically isolated services share the same concept, right? If they all if you need to understand what an order is to work in microservice A, B, and C, and it's the same concept, even though they only touch on different aspects of order, then they're logically it's one bounded context, right? It's one logical grouping of concepts. That's sort of the idea that I try to, and if you do DDD, the idea is, of course, that you're much more deliberate about your design choices. You will still have a mix of things, right? DDD is not sort of a perfect world. People think, somebody this morning told me, I'm doing DDD for the first time now because it's a greenfield system. I finally get to do it. Well, that's sort of misunderstanding it, right? Or not using the opportunities. The idea is that you do design whatever your constraints are, right? So you can choose to have a little bit of a big ball of mud here that you leave there because it doesn't serve the business to fix it. You can have other stuff where it's better organized. Anyway, I sort of want you to forget about technical boundaries and domain boundaries and really talk about these concepts and how they group together. So in our first model, they're really separated, right? Except for this one transition, maybe. Now let's bring in some reality, right? So first of all, I already hinted at locations, right? Because fundamentally, if you need to do order picking, you need to know where stuff is. And if you do put away, you need to know where to put stuff, right? So this idea of locations is already going to be shared between these two areas, right? You cannot understand fully how outbound works if you don't know what locations are. That's the kind of connections I'm talking about, right? We're really trying to look at our systems as groupings of meaning, right? Concepts. If this sounds fake, we do this stuff all the time. It really works. It helps. It's not just sort of ivory tower architecture ideas. But it can be a bit of a mind shift, right, to think that way. So, you know, the system is already a bit more complex than the pretty picture was showing. In fact, my heuristic when I go to clients and they show me an architectural diagram that's sort of nice boxes and well-aligned, I ask, is this what your system really looks like? Because if it looks this pretty and simple, why am I here? Right. So the pretty picture, remember this for the rest of your life. If somebody shows you a pretty picture of an architecture, it's probably a lie. So let's make it a bit more complex. Expedites. An expedite is when, for whatever reason, the customer wants it or any reason, right? We need to move stuff a lot faster, right? We give it priority. It needs to go on an express delivery. We need to order pick it faster, etc. What happens in a warehouse? You know, we have this stuff coming in, but we know it actually needs to go out really fast. So let's not put it in the warehouse and assign it locations and everything. That's way too slow, and then we have to get it back right away. That's a waste of time. Let's just skip the whole process, right? So people in inbound now need to know, there's stuff arriving here that we shouldn't put away. We just keep it here somewhere near the exits, near the docks, and then as soon as the truck arrives, we just put it in the next truck again, right? So it's the sort of optimization. People do it on the ground in sort of a simple warehouse. Well, not necessarily a simple one, but sort of the sort of warehouse where there's a lot of local knowledge happening, right? Where somebody from sales calls and says, hey, we're going to have to move this product really fast. Okay, no worries, we won't put it away, right? That sort of communication is happening. And then people have sort of their local optimizations to do these kind of things. But already the picture gets a bit messier, right? Or beautiful idea of 3 distinct phases is now corrupted some more. In fact, I mentioned orders. They have to be on here somewhere, right? And if you do expedites, you need to understand what the concept of order is, which is now not just living in the outbound boundary anymore, right? So I'm basically showing how the boundaries get messed up if you add some real world to it, as opposed to our sort of naive model when we started. Value-added services is anything. It can be from, we add manuals in the language of the customer. Like they do that in the warehouse. It's not necessarily in the factory or in the assembly line that they do stuff, but there's stuff that they do in the warehouse as well. Could be adding stuff, could be like adding a charger for the local plugs or something. It can be cutting up stuff or reorganizing. I don't know. I've done this sort of system for textile distribution, and they would put these big rolls of textile. They would put them on big machines, roll a piece and cut it to measure for the customer. So that's called value-added services. How does that work? Well, because somebody, the customer asked that, it happens, but they talk to sales. Now you need to know a little bit about these value-added services in outbound. And then, of course, I didn't put it on this picture, but maybe somebody already knows that we will have to cut up these rolls, so instead of moving them straight to the put away and then when we do outbound, move them to the cutting floor, we skip that and we go, this sort of optimizations that people do, right? Or if you have another example here is repeat cuts, right? If we have two customers who both want a piece of the same roll of textile, we're not going to put it away in between as well. So now in value add, you know something about different orders, right? Not just a single order, but you have a bigger sense of what is happening. Maybe you know, oh, this is a very popular thing, or we've just done a campaign about this, and now everybody's ordering this bit. So we're doing these sort of optimizations as well. So now inbound needs to know about value-added services. Right? There's other problems, right? There's quality control. In an ideal world, we just added right there, quality control in the corner, but inbound. So stuff comes in, we do quality control on it, right? The problem is, this is sort of an expensive process, right? We have to take, if it's a textile, for example, we have to take it, we have to roll the whole thing off, check it for inconsistencies or whatever, bad coloring, I don't know, roll it back and put it away. So we're not going to do it on everything. We could have a rule like we do it on 10% of incoming stuff randomly. That could work, like maybe that's a good sample size. What really happens is, of course, that if it's very busy, oh, we're just going to do it on 5%, or we're skipping it all away. Or customer support calls us and says, yeah, we always have problems with stuff from this vendor, so we should do extra quality control on stuff that comes in. Also, the people who are doing that, we don't have like full-time quality control staff, for example. They have people who are just working on in the warehouse doing other stuff, but they have been there for a long time, so they know the textile business a bit, and they know what people want, etc. They've seen the returns, so they know what good quality looks like. So you need to move people from outbound, for example, into quality control, which of course disrupts the schedule for outbound, so you have this sort of mess. And on top of that, there are certain customers who complain a lot. So customer support tells outbound, hey, if you're sending something to this customer, do some extra quality control. So our model where quality control is just something we do on inbound is now completely disrupted. We sometimes do it on outbound for specific situations and customers and whatever. Right? So yeah, let's add a bit more to the mess. I mentioned customer support a few times, right? They are somewhere on here. Where did I put them? Up there. Well, here we just talk about quality control, right? But as you can already imagine, they're going to have more connections to everything else. Yeah, I mentioned this, so more, the staffing problem. We haven't really put staff management on here, but I think over there, it's maybe a bit hard to keep up where I'm adding stuff. So now we have to bring in who is available where, right? If we have, like, this person is one of our experts on this kind of product, they need to do quality control, but they're also assigned to doing outbound stuff, or they're assigned to something else, or how are we going to manage these resources is now a problem that sort of reaches in different places. And yeah, as I mentioned, sometimes we skip it, so you need to know something about the whole, right? If we have a lot of orders, we're more likely to skip it. So you're not just looking at it from a single shipment coming in or a single order going out, but also what's our volume that we have to process today. Right? I can keep going, right? We have all these local optimizations by people on the floor who just know stuff and see how the warehouse works and change it. But then they go to software development and they ask for specific changes in the code, right? And same from sales, they have like insider information that they spread, which is now not even reflected in the software system. That sales talks to the floor directly and calls them and says, hey, can you make sure that this stuff happens really fast? So it's all these local optimizations, right? In how people communicate, what actions people do, what the sort of features that developers are asked to add little bits here and there to optimize things. So there's no, if we look at this from understandability, it's not there. Nobody understands the whole system anymore. There's just little bits of things happening everywhere that might even be different from person to person. I think I added sales on here somewhere. I think over there and at the top. Now, what a warehouse does, it tries to, or good warehousing software, it tries to optimize the walking distance, right? Because if you put something in the back of the warehouse and you have to go get it 20 times a day, you're doing a lot of movement, right? So what you try to do is the stuff that needs to go out very frequently, you keep it at close to the exits. The stuff that is very rare or that is maybe seasonal, maybe the Christmas stuff in the summer, we move it to the back. Things like that, right? So you have this concept of optimizing how the locations work. And you can do that based on historic sales and forecasts and trends and seasonality campaigns, marketing campaigns. So now we can put forecasting on here, which somewhere, whatever. I know what you're thinking, right? Mathias is just very, very bad at drawing these diagrams. Don't worry, I got you covered. Let's add some color. No, but these things like forecasting, I call them octopus domains. They have their tentacles into everything, right? They need to know about all kinds of different things to do their job. Same with all these kind of problems, right? Returns and failures and wrong deliveries and partial deliveries, and then rules about because these, like if we keep the textile example, this stuff is used to, for example, make furniture and cover it with textile or curtains or stuff. And if you're trying to make like a sofa with 2 types of textile and you only have one, you're not starting on that. So you don't want a partial delivery. You either want all of it or none of it. And I've done this sort of stuff with like global supply chain shipping for car manufacturing, etc., where it's even worse, right? They do this just-in-time assembly lines. They don't want to have a bunch of stock. If they need 1,000 of A and 1,000 of B, but you can only give them 500 of A, they only want 500 of B. So there's a lot of this sort of messiness that doesn't fit anywhere. And so in this example, customer support is another one of those octopus contexts, right? They need to solve these problems. They need access to all of that. They need to be able to manipulate things across the whole, as you can clearly see, things across the whole system. So everything is deeply dependent on each other. We are taught this, right? Dependencies are bad. But I think that's the wrong way of looking at this. Software wants to be connected, right? That's why it's successful. That's one of its defining features. It's this connectedness. It used to be that if you wanted to connect 2 pieces of data, you had to send a letter to some archive somewhere in some different place, and they would look in their index card and copy it on a letter and send it back to you. So connectivity wasn't really a big thing. And as soon as people started discovering they could connect all kinds of data, that's when software exploded, really. And now if you don't do that, you're basically losing out. And so expedite as well, right? One of those octopus domains, the concept of what is an expedite, right? So at the heart, it's a simple idea, right? There's stuff that we need to move faster throughout the system. But you can't understand it anymore because everybody's doing these local optimizations and probably the whole system is worse because of it, right? The whole system is deeply slower than it should be because of the local optimizations. There's a lot more theory about that doesn't really matter here, but nobody can look at the system and understand how an expedite actually works and how it actually gets faster, right? Because there's so many little things. There's hacks in the code. There's local, manual things that people do, local decision making. I've added it here as well. I know what you're thinking, right? The colors really bring it together, right? No. So what if we take that idea and we put it first class, right? What is this problem? What is this system really trying to solve? It's not just moving things inbound, put away outbound. It's trying to do it efficiently, right? So there's no efficiency domain, right? But what if we take efficiency and make it a first-class concept in this thing, right? Much better picture, right? Of course, I left all the other stuff out. That's cheating. But we can put efficiency at the heart. We can rethink how the concept of our system works, what the purpose is. We don't need that. So that's the underlying business need, right? We need to not just deal with these resources, but we need to do so in an efficient way. I mentioned this. So before it wasn't solved globally. Now we're saying, what if we make this the heart of the system? What if we design the system around the new purpose, which is efficiency? I keep saying things, then showing the slides later. That's because of lack of rehearsal. But that's the idea, right? So efficiency becomes first class, and we're moving that into its own bounded context, right? Just as a repeater, domains is how the business perceives itself. It's the activities and the knowledge that it's doing. There's sort of its core domain and subdomains in DDD terminology. Some of them are supporting the core domain. Some are just generic stuff that everybody needs, like invoicing. We can organize around that, but we can organize for what works for us, what works for the organization, what is the purpose of the system, right? So this idea. So imagine this now, right? We have a single place where all the concepts about expedites belong, right? Nobody said make a system for the efficiency domain, right? It didn't exist. It's not something that came. It's not. We treat domain-driven design a bit too much as a one-directional thing, where or software design in general, right? Somebody looks at the business, writes down all the nouns, puts them in code, and now we have a working system. But reality just doesn't work that way. It's much messier. And often you can't see these things early on, right? You need to sort of spend some time with the problem and ask. I like asking a lot of naive and stupid questions, because then you get answers to this kind of stuff. So imagine now that this is its own thing, right? Where all the terminology about efficiency is grouped. Everything like expedites, things like that. We can deal with staff availability and priorities. This sort of language, right? All this language about priorities and expedites and efficiency and staff and optimizations is all together in one place. We give it like unambiguous definitions, right? We model it, right? Instead of doing local hacks, we now model it as what is the thing we need to solve efficiency. And then this other, not just these three, but all the other ones as well, everything that has efficiency needs talks to this thing. So nothing makes decisions themselves anymore. We centralize efficiency as a concept. Everything else needs to ask for stuff. So I want an expedite. Well, I will tell you if you can have an expedite, because we already have 3 expedites running, and we now know in a central place that we cannot have more than 3 expedites at a time. That's like a rule that we put in there. So it goes on a queue. Or something else like quality control. Yeah, we want to skip quality control. Well, no, you can't, because we've done it too much already. We have rules about the range of minimal allowed and maximum allowed time or effort we spend on quality control, right? So we organize all these concepts centrally. We model it like it's a real, as if it's a domain, except it's not a domain. It's a new bounded context that we as designers invented. Of course, it's based on the domain. It uses all this language from the domain, but it's seeing this problem as a standalone first-class problem now. Is this making sense so far? Because that's like this central idea. If you lost me here, that's a good time to ask questions. It's centrally controlled, right? The other components cannot decide, hey, I'm going to pull you away from there. They need to ask the efficiency model. There's availability, there's priorities, you could manage skills in there, for example, right? This person is skilled to do this kind of quality control. So you could even add slack time in there. We could say, well, we often need expedite quality control that only this person can do. So we're never going to book that person's time 100%. We leave slack time, and then when an expedite happens, we can actually put that person there. We know that we have at least 20% of their time available for unexpected stuff. If you know something about theory of constraints, that's basically the idea here, right? It's theory of constraints as a model, or as a service. If you haven't read the book The Goal by Goldratt, it's very good. It's written in a very annoying style, in my opinion, but it's a very good book, so you should read it. I think it's important for software people to know that stuff, and for your project manager as well. But you see where I'm going with this, right? We are rethinking it. We are doing actual design, right? We're thinking about purpose. We're thinking about our constraints. We're thinking about the needs and the direction of the business and the needs of our customers, if this is like a warehouse management as a service system. And we look at it not from sort of, because if you build a warehouse management system, right, every competitor you have will do inbound, put away, and outbound. They all have those features, right? You cannot compete on that. If you don't have them, you're not even a warehouse management system. What do you compete on the stuff like this, right? If you can do it more efficiently, if you can minimize walking distance and do expedites properly, etc., and they see an actual improvement in how fast they can deliver stuff. Now you're in business. Now you can compete. That can be your USP. If that is your USP, if your marketing people are putting that on the website, or WMS is more efficient than anyone else's, how is this software design not even reflecting that, right? That's sort of what I'm talking about. Software design as not just sort of a transfer of concepts from a domain into code and just sort of make the rules work and just add more if statements whenever somebody asks for something. It's rethinking what belongs together and what can be separate and how we sort of structure it and what benefits us, and even going further where which is sort of not the topic, but I'm working on an essay about it, so I'm like wanting to tease it now. But if you can do that, if you can separate things like that, you create more room for things like experimentation, for can we try some crazy idea that somebody has, where we can just conceptually separate that, play around with it, get rid of it if it doesn't work, and move further, right? So we can actually use software design in the opposite direction, which is finding opportunities for new directions for the business, right? We've been too much trained in this sort of machine mindset of software as a manufacturing process where, requirements go on the pipeline and at the end, software and bugs roll out. No, it should be a design process. I think that Agile sort of also accidentally, because it wasn't in the original mindset, but Agile became this sort of, let's just do 2-week sprints and everything needs to fit in there, and there's no room for this sort of real, like, figuring out what's really happening. Should we rethink this? Can we play around with this for a bit? Get rid of it, try it again. But I won't rant about Agile. It's like it's still my darling. I still love Agile. I just don't like how it's done most of the time. Anyway, so this new model, right? It's self-contained. It can sort of stand on its own. Maybe not 100%. It's not like this fully independent thing that doesn't know anything about anything else. But you can look at it without having to understand the details of inbound, the details of outbound, etc. Right? All these other domains. You don't have to understand the details because it really talks only in this language of expedites and efficiency, etc. So it's much better isolated. It's not fully decoupled in the sense that these other domains need to talk to it. But the way they talk to it is very precise. And you can start thinking about what language do other components need to use to talk to this bounded context, right? You could say they only talk in the language of efficiency. So the ownership of the contract is at the side of efficiency. Or you could turn it around and say efficiency has this sort of translation layer where it knows how to talk to inbound, it knows how to talk to outbound. So efficiency is aware of the language of each of these things, but sort of isolated in the communication paths. Is that making sense? So if you look at an API where a lot of the complexity happens, especially if you have more smaller services, then you'll have more complexity in the connections between those things. You start thinking about that language as well, right? Is this interchange language, this contract language, is that understandable in its own right? Can I reason about that without having to understand everything else? Is it doing the minimal that we need to have A and B communicate with each other without knowing anything about each other? Right? So it's almost as a consequence of this drive for clear language and isolated and boundaries that you get understandability as a result of the system. And I know that some of this would take like years of development work, but of course you're going to focus on which areas are more important or more critical moving forward for the business, etc. But it's also internally consistent, right? I want to stress that point as well. You can look at it, and the language is, when something says expedite in this, because we have this nice boundary, this model, when something is named expedite in there, it's clearly defined, it means one thing. Before it was, somebody from sales has a definition of expedite, and somebody on the floor has a definition of expedite that they probably never even formulated, right? It's not their job to have this clear domain language and define that very well and agree on terms. They're not designers, right? They work on they evolve their language based on their needs. Language is always social and organic, right? If you work on the floor, you'll develop a language and a sort of shared interpretation of what is an expedite, but the salespeople think about it different and the marketing people think about it differently, etc. We as designers need to figure out that mess, right? Look at the language, look at the meanings and say, well, when you talk about expedite, is that really the same thing? When you talk about it, what do you really mean, right? What happens? You could use bounded context to say, in this context, we'll define it like this, and in this context, we define it like this. In this example, I'm saying, let's just have one definition for expedite, but you can start playing around with that, right? Because now you have language in a context, language within a boundary. Right? So you can have different definitions, but it's clear within the boundary. Here it's internally consistent. This is what it means. Here it means something else. It's internally consistent. Making sense? All right, smart audience. I like it. Oh, sorry. Yes. I have a more formal-ish definition here. So a consistent model and a language within an explicit boundary. Explicit in the sense that everybody in the team agrees on it and knows and has like this way of thinking about, some new concepts. We need to build something new, a new feature. We understand that it belongs here or it doesn't belong here, or we have like a shared, or we have maybe like modeling sessions where we figure out, does this really belong here? Is this really the same thing? Is this something else? So basically what domain-driven design advocates is that thinking about the meaning of stuff becomes an explicit part of the development process, not some fix that you have to do like later when you figure out that nobody understands each other. You make it a real part of system development, right? What we're really doing is translating knowledge into working systems, and that knowledge is usually messy and all over the place and contradictory and ambiguous. Software doesn't really work well with that sort of ambiguity. We need to figure it out. It's our job. People will sometimes say, oh, it's the analyst's jobs. Yes, true, but in the end, if the engineers don't understand it, that's what gets into the software, right? It doesn't matter how well, the customer understands it or the analyst or whoever, but if the engineers don't understand it, it's not going to be clear and explicit in the software, right? Yeah, I guess we talked about this a lot already. Just another reminder, right? It's not technical. But you can do it. Ideally, we say this efficiency thing is one service with one API, etc. But for whatever reason, it could be more spread out across different services or whatever. Right? But it's what works for us, right? If it works for us to keep it the way it is, I'm not saying, oh, the better software design here is to split it off and whatever, right? If it works, if it is actually efficient that way, if people understand it, don't touch it. Or if we don't care about efficiency, don't touch it, right? It's not sort of this, like we tend to treat software design as a problem of elegance and beauty and stuff like that sometimes. I don't care if it's ugly, if we can understand it and work with it and it's productive for us. Or if we don't need to touch it anymore, I don't care that it's ugly. I'm just worried that will we need to touch it again, and then it's worth touching it. And it works in both ways, right? Because the more you extract concepts, this expedite concept, for example, that was all over the place, the more we extract that, the more clear the expedite concept becomes. But these other parts become more clear as well, because they don't have all these if statements in between that suddenly, why is this, if customer ID equals 17, then skip the quality control or something. Like a lot of knowledge gets lost that way. If we can pull that out and it's clearly in the expedite context or the efficiency context, the other stuff becomes clear as well, right? And you have this Mikado effect where you take the obvious stuff away and now say, oh, here actually this is still like mixing two concepts. Can we pull that apart? And it becomes easier and easier. So the stuff I'm talking about may seem like big investments, but they have this sort of long-term compound effect, right? Where it becomes easier and easier to do stuff like this. And in a mature environment, the sort of system you end up with over time, right? And don't stress it if you're not there yet now, but instead of sort of quick features and hacks, and then people say, oh, this would be way too much work, it's too complex, we can't do it, it's not worth it, etc. You get this sort of environment where somebody has an idea and you can just sort of try a quick proof of concept because it's clear where it fits and where it doesn't fit. And we've probably read these sort of statistics, right? When coding, we spend most of our time reading code and not writing code. That's because we're trying to understand what's happening and where we need to fit the next thing in, etc. And we're sort of always in this reverse engineering mode, trying to understand the code. If you have this clean separation based on meaning instead of just technical separation, that sort of goes away for a large part, right? The system communicates its intent. What's the intent of the efficiency boundary? Well, clearly to make other things more efficient, right? That becomes very, very obvious. I promised a few heuristics, so this is the basic idea of this talk, of course, organize around what needs to be understood together. One little trick I sometimes use, like it's called an intuition pump, but don't worry about that. But imagine, could efficiency or expedite work as a standalone third-party SaaS product that we just integrate with, and we send it messages about staff availability, for example. Can I have some staff to do this task? You could sort of imagine that would work, right? You could maybe they even exist, I don't know, but that you could buy this off the shelf and integrate it with your product. If you can imagine that, that's already a good heuristic that probably you should and you could split this off as a separate bounded context, right? Stuff that changes together, right? If you, like the expedites, if we want to change how that works, if we have new ideas, we learn new concepts of how to organize warehouses more efficiently, we're going to have a period of rapid experimentation around these new ideas, right? These are all sort of concepts that are going to change together. Let's group them together, right? This is not just sort of single responsibility at the object level, right? This is at system level, at organizational level of the system. What is going to change together? What is not going to change together? It doesn't need to be together, maybe. Right? It's just sort of heuristics, right? Little tricks to sort of see different angles of how to do things. I already talked about this a bit, but if something is very stable, right? The way locations work, right? In the end, that's not going to get a lot of innovation, right? You have the warehouse, there's rows of stuff and places with numbers, and you can put stuff in there. And take it out, obviously. That's what the concept of a location is in a warehouse. That's not going to change heavily. So what is going to change is maybe how we organize that. What do we put close to the exit and what not? And are there other ways? Or maybe organize things together that always need to be order picked together. That might be another optimization, right? We always need these two parts at the same time. So let's put them in two locations close to each other. So instead of thinking of locations as this one big blob of things, you can see it as two parts. A stable part, which is just the physical structure of a warehouse. Where are things and what location IDs do they have, etc. And then what is variable, the optimizations or the organization of how we put stuff in locations, right? So if you see this now as two conceptually separate concepts, one is infrastructure, one is usage of infrastructure, right? It's like two layers on top of each other. And the bottom layer doesn't need to know anything about the top layer. It just says, here's the space I have, this is how much stuff is in here, this is full, this is empty, this is close to the exit, etc. So you have that model, and on top of that, you can have a model that talks about the knowledge of where to put stuff or how to move things around in there, or etc. Right? It's somewhere in the back of the DDD book, which most people haven't read the second half anyway, but it's called Responsibility Layers and Knowledge Levels, if you want to look that up. But it's this idea of not just, we're talking about a single domain, right? It's the warehouse locations, but we're seeing it as two bounded contexts, right? The physical locations, the stable part, the variable thing, which is how, where we want to put stuff for specific reasons, for optimal reasons or for whatever, right? And another one is, I talked about how, the more boundaries you have, the more communication we'll have between these things. So you can start drawing that, right? There's techniques like in event storming, etc. You start drawing not just, there's going to be messages between these two things, but this is sort of the language, this is the concepts that these messages talk about. And you look for, is it mixing concepts, right? Is a message or a set of messages talking about both expedites and locations, for example? That's a smell, right? Something is happening there. This API is covering too much different conceptual things that we could probably separate. So if you start drawing this sort of thing, you can get a clearer picture of what needs to know about what. And then you can start working on, we reduce what needs to know about what. And now if you have components that need to know very little about other things, you have these small boundaries of really understandable stuff. Where changing it becomes cheaper, or just leaving it somewhere and never having to touch it again becomes more easy, and the whole thing becomes a much nicer and productive software development experience. Thank you very much.